Again, we have another real-life example, talking about some muskox and some caribou. What we know is that in 1955 there were 9,250 muskox, and as the years went on, this population began to grow, and it grew at 1,650 per year. What we'd like to know is how long it'll take for the population to reach 100,000 animals. Go to our formula. T1 being our first term, so at the beginning of the sequence, or at the beginning of the time period, would be 9,250. D, the change per year, that would be 1,650. And the other valuable piece of information here is we want 100,000 muskox. That is actually Tn, and N is what we don't know. And if we think about this and use some common sense, that should make sense. We wouldn't be counting out 100,000 years. It would make more sense to have 100,000 animals. So unlike the first example, now we're trying to find N, just changes the math a little bit. There's our formula. We can fill in what we know. Would help if I actually filled in D there. Easiest thing to do first would be to subtract 9,250 from each side. We've got two options. Probably the simplest one would be to distribute the 1650 in on the right. We'll add 1650 to both sides. Last step would be to divide by 1650, and we get that N is 56. 56 years in this case. So it'll take 56 years for the population of muskox to reach 100,000. Now that won't be in the year 56. We know we started the sequence in 1955. So if we add 56 years onto 1955, that means in 2011 the population should have been 100,000.